My name is Nicholas Outar. I am using the circle saw to cross cut this plywood.
This is a lid, and I will be powder turning this workpiece to a diameter of 2 inches.
Good afternoon, good morning. Today we're looking at a 3Y engine from Toyota, which is a 4-stroke, 2-valve per cylinder, 1800cc engine. We can start from the top, move all the way down. We have the valve cover, then we have the rocker arm with the rocker shaft assembly. We have the valve retainer, the split clip which holds the valve in place. We have the valve spring which pulls the valve up once it is closed, close the valve once it's open. You have the valve itself, and this is the valve seat, where when the valve is closed, it creates an airtight seal where compression cannot leak out. You have the cylinder bore itself, where the piston resides. Now, the piston is the thing that makes the power move to the crankshaft, which in turn turns the wheel through the transmission. On the cylinder, normally the piston is being made out of aluminum or cast steel, but this one is aluminum. On this piston itself, it has ring grooves where the piston compression rings and oil scrapers are located, which are these right here. Now, through the piston is a hole on the each side where you can see where a pin goes through that connects the connecting rod with this component to the piston itself. Now, between these two pieces, which split apart, there's a bearing. That bearing reduces friction and does not cause any damage when oil is there. Then we have the connecting rod cap, which holds everything together and gives something named a bearing crush. It compresses the bearing enough and gives an adequate space in between where oil can flow. Now, this attached to something named the control or the Conrad journal. The Conrad journal is the thing that turns linear motion into reciprocating motion. In other terms, it turns up and down movement into circular motion. Right? Now we move on to the most important part of the engine, which is this. This is the oil pickup. Right? It sits in the oil sump and provides the engine with adequate oil for lubrication. Without this, you can have major engine failure. Attached to this is the oil pump, which circulates the oil throughout the entire system and causes the engine to operate at an efficient manner. Now, moving to the front of the engine, we have the power steering pump, which supplies hydraulic pressure to your power steering rack, making your car easy to turn. We have the belt tensioner. It keeps this belt under tension and making it not to come off or keep it in place. Right? We have the water pump, which has the fan belt mounts. It keeps the fan mount, that keeps the fan on for cooling. We have the crankshaft pulley, which gives drive to the accessories, including the alternator, and you might have an AC compressor. In this case, we don't have one. Ignition system, which technically produces spark, which combusts the fuel. We have the distributor, which distributes the electrical pulses into its adequate firing order, which is, in this case, is a 1-3-4-2. Right? We have the ignition leads, which go to the spark plug, and the spark plug is what generates the spark inside here, which generates the spark to combust the fuel and air mixture. We then have the fuel lift pump, which provides fuel pressure to the carburetor, which is not situated here. We have the oil filter, which filters the oil out of contaminants and keeps it clean. Then we have the oil pressure sender. This connects to a gauge inside of the cabin to show you oil pressure and whether it is functioning or not. We have the starter. The starter is what turns over the engine. Now, when the crankshaft turns, right, it acts on the connecting rod, which moves the piston up and down. Now, in front of the crankshaft, there's a gear which connects to something in the camshaft, which also moves these valves up and down in order to open and close them according to the firing order. And then these rings here grip the side of the cylinder bore and keeps the compression inside. This is also turning the oil pump, which sucks oil from here and distributes it throughout the whole system. And it also turns the accessories, and the lift pump on the other side is moved. Well, this here is the suspension, steering system, and brakes trainer. We have the steering rack, which is this, the steering rack end, which is this component here, and then we have the steering end, which is from here to here, right? We also have the brake disc, which is this, the brake caliper, and then in between the brake disc and the caliper, there should be something called a brake pad, which when hydraulic pressure is acting on the piston inside of this component, squeeze the brake pad together and creates friction. It slows down the vehicle. We have the strut or the shaft tower. We have the upper part, which holds the spring into place. The lower part or the seat. We have the shaft pole. And this is the chamber, which is filled with oil and dampens bumps on the road. Have the lower control arm, which moves up and down with the entire suspension system. Has some bushings to dampen that also. On this part here, we have the rack and pinion. This is the rack, and this gear here is the pinion gear. When you turn your wheel, it turns this helical drive, which pulls or pushes the steering part in any direction, depending on where you turn it. Right? Here we have the brake servo. This is the brake fluid reservoir. Inside here, there's a piston and spring. When brake pressure or pressure is applied here, it squeezes brake fluid into the caliper. And this part is a different setup. This is the drum brake. Same concept, but instead of a disc, there's a rotor. And this here is the brake shoe itself. A handbrake, which is the emergency brake. When you activate this, it pulls a cable which squeezes the brake disc, the brake shoe on the drum, holding the vehicle stationary.
Yeah, here we have a medium performing arc welding, tacking mesh towards the angle iron.